All right, good morning, everyone. Thank you for joining us for the HPC Best Practices webinar. Today, we're going to hear from Stephan Druskat at DLR, who'll be telling us about practical software citation. We handle questions for these webinars through a Google Doc for Q&A, and the link is here. I'll put it in the Zoom chat as well. If you forget and put something in Zoom chat, I'll try to translate it over to the Q&A. And we'll use the Q&A document to ask Stephan questions as we go along. We'd also very much appreciate your feedback from about this webinar. If you would like to give it, it's just a couple of questions and a quick survey. And of course, after the webinar is over, we will post the recording, the slides, and the Q&A. And anybody who's registered will get information about those. So please share it with your friends and colleagues who might be interested. And with that, I'll turn it over to Stephan.
Thank you very much indeed, David. Welcome to this webinar where I'll try to give you a brief overview of practical software citation, how it can work in practice for mainly two groups, which is people who develop research software, but also the users of research software, which usually will be researchers. A few words about myself. I have a background in the humanities and then worked as a research software engineer in a couple of linguistic research projects in Germany, where I'm based, Berlin, Germany, so it's early evening for me. I've become a fellow of the Software Sustainability Institute, which is a UK institute that tries to make research software better so the research can be better, because I got interested in software sustainability and what happens to software after the project is over. From this came an invention of mine, which is a citation file format project. You'll hear about this a lot during this webinar. And I've then changed over to the German Aerospace Center and the Institute of Software Technology around about 2019, where I now work as a software engineering researcher. Also kind of relevant to this webinar is another project I'm currently doing, which is called Hermes. And we're looking to automate software publication with rich metadata to make the research software fair. And finally, also something that'll come up during the webinar is the Research Software Alliance Task Force Software Authorship and Contribution, because there is still some work to do in this respect. So what will I try to cover in this webinar? I'll start off with kind of short introduction to what we mean when we talk about software citation. And I'll then try to provide practical software citation guidance for people who develop and maintain software before switching to the user side and talking about what you can do when you cite software yourself, and then give some final remarks in the end. Right, because we have a lot of ground to cover, let's dive right in. So why do we need to talk about software citation at all? From the perspective of an academic researcher, this should be relatively clear. It is because we advance knowledge and we rely increasingly on computational methods, and we use software to get to our research results. And as researchers now, we have an obligation to disclose all the methods we've used, and that includes naming the software that we've used to get our research results. From the perspective of research software developers or research software engineers, short RSEs, we also want to make our software available and disclose that we have created it, participated in its creation, and that's a matter also of accepting a degree of accountability for our work. If that works, then in return, we can receive credit for the work we've done with the software. And the way this traditionally works in scholarship, as we all know, is by being cited. Formal citation has been an established method of disclosing the previous work that our research builds on for, I guess, over 100 years at least now. And by formal citation, I mean that you link the parts of your research that rely on or relate to specific previous work to this work. And the way this works in practice is you provide a reference to the previous work that allows then others to find it and also look at the link between the previous work and your own work, your own research. And these days, now that we heavily rely on software for the research, we should also formally cite the software that we use. And so basically software citation, just like the citation of any other research output, has a number of functions. And I think the most important ones in this context are first, the acknowledgement of the importance of software in and for research as such, which we hope that in the long term, it'll lead to better acceptance and support, and also better funding and credit for work around research software. Formal citation also can improve findability of software as part of making the software more fair. And fair is short for findable, accessible, interoperable, and reusable. Has been applied to research data in the past and is increasingly being applied to research software as well. Software citation is also important for improving the reproducibility of research, because when we clearly identify the software that has been used, we provide at least part of the recipe for understanding the research and reproducing the research, and also evaluating the research. And last but not least, and I'm saying this as an ex-RSE, or current RSE in some respects as well, software citation can provide credit for those of us who create and maintain research software. Because sometimes we do this work at the expense of writing papers or undertaking other research ventures that would normally provide this credit so that we can build a career on it. So how does software citation work? There is a 2016 paper that's crucial to this question. It's called the Software Citation Principles. And unsurprisingly, it lays out the principles of software citation. I'm going to very briefly introduce them. The principles are: first, software should be considered a legitimate and citable research output. In the scholarly records, software citations should be valued the same as citations to papers, for example. And this basically means that software should be cited just in the same way that papers are cited these days. Also, software citation should provide credit for and attribution of software authors. So that means that the authors of the software should be named in the citation, and ideally with their first names, not a kind of collective group name or something. Software citation should include a method for the unique identification of the software, which usually it means a DOI or another persistent unique identifier. Identifiers we know from other outputs, such as papers, for example. And that identifier should be machine readable and resolved to the actual software artifacts. And also these unique identifiers and the metadata that are usually attached to them should persist even if the software is gone. This means that the software should somehow be published, and what publication in this context means I'll talk about later. Software citation should make it possible to access the software itself and all the stuff that goes with it, so documentation, instructions to run the software, etc. And that's so that other people that find the software can also use it. And finally, software citation should identify the specific version that was used in the research that cites it. And that's because this is important for being able to understand, evaluate, and reproduce the research if we're so inclined. Right, so far so good. These are the principles, but why are we holding webinars like this that discuss software citation and not webinars that talk about citing monographs or papers? That's because software citation is not only less accepted than citation of other works, it also comes with some challenges. And these challenges are something I'll talk about now. One of the main challenges in software citation is the actual metadata we need to cite software. And cite software also according to the software citation principles. We know very well how to cite papers because papers come with a title page, or at least a website, publisher website for the paper. And the title page or website always includes all the metadata that we need to cite the paper properly. Software doesn't usually have a title page, at least not in the formalized way that papers or books provide. Sometimes have a README or other ways of providing some of these metadata. So just from having used the software, it's often more difficult to find out for us as users, for example, who the authors of the software are, especially the authors they should cite. What's the publication date of the software, perhaps also what the version of the software is that we used. And sometimes we don't even know the name of the software that we should use for citation. And just as a side note, there are These are the metadata that describe the creation and the maintenance, and this is what we need for citation. If we go one step further and want to look at reproducibility, we need more and also other metadata as well. And these metadata should describe the usage of the software in the research, not as creation. This is a different topic, different webinar maybe, and I won't get into these metadata today and their challenges, but I'm very grateful to Dan Katz for bringing this distinction to my attention. Now, the software metadata that are needed for citation, they have to be defined and provided in a form that makes them usable, ideally both for people that look at metadata, that find the metadata, want to cite software in their paper, but also for services that need the metadata in a machine-readable format. For example, indexers that want to find out what software has been published, in which versions, etc. So the projects where the software is developed are actually the only places that can determine the complete and the correct citation metadata for the software, for every version of the software, etc. And therefore, it's the task of the developer, the developers and the maintainers to provide the metadata. And how you can provide the metadata is what I'll get into now. And this is the part, practical software citation for developers and maintainers. So how to make your software citable? The first step is to determine what metadata should be used to cite your software. This may sound relatively easy, but it can actually be a lot more complex than one may think, especially when it comes to authorship, for example. So for papers, there are guidelines that define the author role, the rights that come with the author role, the responsibilities for journal articles. But currently there is no such thing for software. And this is why we're currently developing guidelines for software projects around how to determine authors in a Research Software Alliance task force called Software Authorship and Contribution. That's work in progress. There's a link provided in the slides, and the slides are going to be shared as well. So you can click through to that task force if you're interested. In the task force, we look at criteria for authorship, also the threshold between what we usually call contributors, so people that may fix a typo in your repository, and actually authors. There is this notion of us making a substantial contribution to qualify for authorship. I think the main point here at this point in time as well, before we have these actual guidelines, is if you have a software project, think about how you want to define and how you want to award authorship, and find a way to document this authorship policy. This could be a file in your repository, for example, so that people can understand what it takes to become an author of the software. Another challenge is getting a unique, persistent, and resolvable identifier. It's not actually that hard. It can be done through publishing your software, which is what I'll talk about coming to point 3, step 3 of making your software citable. And beyond that, some software engineering basics apply, such as you should use version control, you should identify the versions that you think are fit to be used by others, for example, by tagging the versions and creating a release. And once you have all these metadata, you can supply them in a file in the root of your source code repository. And that's the practical part of making your software citable. The file should be called something like citation, all caps here, because that's also how you name files like the README, which is basic documentation for the software, a license file, or a contribution guide. And as already mentioned, the next step would then be, once you have that metadata ready and provided in your repo, you publish your software to get an identifier, to get a persistent identifier for the software. And you can publish the software in an open access repository, for example. One well-known example for open access repositories is Zenodo. And Zenodo, if you publish your software there, will get you a DOI, or actually 2 DOIs, one for the actual software version, and one that collects this and every subsequent version of the software you publish there. Or you can archive your software in the Software Heritage Archive, which also provides identifiers that are unique, persistent, and resolvable. And I'm going to introduce these identifiers in a bit as well. Once you've done that, what's left to do for you is the process of maintaining the metadata. Do that together with your software, evolve the metadata together with the software, and your software will be citable. And then finally, hopefully, you'll see something like as a reference to software as depicted here on the lower right-hand side of the slide. This is not everything. This is supposed to be a practical webinar. And so I'm actually now going to go through some practical steps of making your software citable. So what do these things mean in practice? The main idea for providing citation metadata is that you create a file and you can put that in the root of your source code repo, but you can also package it with the distributable version. So if you ship out a zip file or a tarball to your users, include the citation metadata file there. There are different formats for providing metadata about software. I'm going to talk about the citation file format here because it has a focus on citation and citation relevant metadata. But just to mention them, there is also code meta, which is a more generic, descriptive metadata format for software. It uses JSON linked data, so it's definitely machine readable, perhaps not so much human readable, and there are others as well. And some programming languages have their own standards as well. For example, the R community uses description files. So make sure that you align with what current practices in your community. Why do I focus on the citation file format, or short CFF? Because like I said, it has a focus on citation metadata. It is currently the most widely used format. There are, I think, over 25,000 files on GitHub alone, a lot less files for the other formats. It does have an ecosystem of tools, and it also integrates with some relevant tools and platforms. I'm going to show you some examples for those as well. So this is what you see here on the slide is what a citation file format file looks like. It should be called citation.cff. You have some metadata about the file format itself, such as the version of the schema that's being used in this file, and a message, which is some sort of self-documentation for what people are looking at. And then you have the usual metadata you'd expect for a citation file format. So title is the name of the software. You have a description of the software, a list of authors, a version, which is important, as we've seen in the software citation principles, a release date, which can be taken as a publication date, and then a list of identifiers, and also some metadata that's not relevant for references, but is relevant in other citation contexts. If you look, for example, at dependency trees, and that's the license, and also a link to the source code repository. What's not shown here, what CFF also has, is it supports references. So you can actually cite previous work that you build on creating the software, such as your dependencies, in this file, and you this way can build an actual citation graph of software. Also, what you can do in CFF is if you quickly open the chat so I can track this. If you are in the position where you have to have papers out to be able to build a career on citations, CFF has you covered because it has a field called preferred citation, where you can ask people to cite a paper along with the software as well. And also CFF has some experimental dataset support. Okay, there are a few options how you can create this file. Probably the easiest one is to use an online tool called CFF Init. That's been developed by the Netherlands East Science Center. And that's basically a form-based website which guides you through the creation of a citation.cff file. It validates the metadata, and then it provides a file for download, and you can put that file in your repo. Another option is to create the file in your IDE. That's possible and relatively easy to do because CFF, the project, so the citation file format project, provides a JSON schema file that's being served on the schema store. And this can be integrated in many IDEs. You can see an example from VS Code here. And once you've integrated the schema, the IDE provides the automatic creation of a file stub, for example, so you can, to get you started, provides auto-completion and also validation. And that's really quite handy, especially if you want to, if you've created your initial version of the file and then you want to adapt it, you can make sure that it's actually valid. There is also the CFF website, which has example snippets. It has a tutorial, and the schema guide provides a full reference of the whole schema, We can really dive into the format, and there are snippets for typical files, for files with references, and also for files, an example file or snippet for the preferred citation I talked about. And finally, if you already have published your software on Zenodo, you can actually download a CFF file from this software publication to get you started in developing the citation metadata.
Stephan?
Yes.
We had a quick question about the CFF
Sure.
format that might be timely to answer now.
Mm-hmm.
So the question from Felipe is, the date released keyword is for the current version or the initial release or the initial commit or what?
That's for the current version. So I'm quickly going to jump back. Yes, so that's date release, because we don't have usually a publication date unless we publish the software, is for the version. So this file, if you maintain it with your source code, and people look at a specific version in the source code repository, for example, a specific commit, they should always see up-to-date data ideally. If the version you're looking at has not been released, you can also make that sure by providing more information about the version, not just the identifier, but also a revision it pertains to, for example.
So two things then. There's, first of all, you would expect the version and the date released in this slide to go together.
Mm-hmm. Yes.
And the second thing is the CFF format is capable of representing a lot more than what you've given in this example.
Yes, absolutely. This is a really minimal example. You can have different identifiers, especially. So not only DOIs, but you can have URLs, you can have free text identifiers, and also software heritage archive identifiers. If you really want to learn what you can do with the format, look at the website and the schema guide. There's a lot to kind of dive into.
Thank you.
Sure. Okay, maintenance. Maintenance is of course a crucial part. Ideally, you want to develop the citation metadata together with your software. I know this is another task yet to go on your to-do list, but especially in academia and as a research software engineer, we're in that position where this is the central part of our work. This is what we do. We develop the software, so we want to make sure that it's citable. We can receive credit for that work. And there are some tools that can actually help you with this as well. There is a validation and conversion tool that's called CFF Convert, also developed within the scope of the CFF project. That's available as a command line application, but also as a GitHub action. If you use GitHub for managing your source code, there is tooling available for different tasks and different languages. Doing things like creating files or converting files, editing files, some automation from manifests, for example. So if you have a Python project and you have a pyproject.toml file, there is a tool that can actually sync the two files and sync the metadata in these files. I've already mentioned this at the very beginning. I'm currently involved in a project that develops an automated publication pipeline for software, which runs in the continuous integration pipeline if you use this, for example, to automate your testing. And also this tool and this workflow can be used to update your metadata automatically. Basically what it does is it goes over the repository, harvests metadata from many sources, CFF files, of course, but also code meta, documentation, and some code, the version control system as well. It tries to build a coherent set of metadata that you can look at and curate and say, this looks okay, before it deposits the software and the metadata together in a repository. And the post-processing step is where you can write back the updated metadata into your repository. This is still work in progress. We're not at version 1 yet, but we're on the way to get there. A very brief look at some of the integrations that you get for free when you use CFF. There is a GitHub, it's integrated in GitHub. So when you have a citation.cff file in your repo, you get this nice widget where people can click on it and say, cite this repository, and they'll get a rendered version of the metadata from the CFF file, either as a pre-formatted string or as BibTeX. It also has documentation around this. And we're currently in the process of developing a GitLab integration as well, because that's been an open issue for, I think, at least 3 years. And because GitLab's used widely in Europe, for example, people really want this to happen. The other thing is that there is an automation, publication automation between GitHub and Zenodo. So if you use these two platforms, whenever you can activate this, and whenever you create a release, Zenodo will get the files, the software artifacts from your GitHub repo and create a new deposit. And previously, the metadata was kind of not ideal because they used the GitHub API to get most of the metadata. And now they support CFF, so you can actually have full control over what metadata you supply if you use this integration. And the Software Heritage Archive, which is a project that tries to preserve the, basically the source code heritage of humankind. It harvests openly available repositories, and whenever it finds a repository that has a CFF file, it also gives you this nice citation button here, where again the metadata is transformed into BibTeX, which is something you can paste into your bib file. And there are at least 2 reference managers I know of that support the file in terms of being able to import the metadata into them and then use them to build a references list for your paper, for example. And the last step in the process to make research software citable is software publication. Like I said, this gives you a persistent machine readable identifier. And I just wanted to make sure that when you hear software publication, you have an idea of what I mean with it. It is software publication with a PID, ideally in a repository, which gives you a DOI. Another good version to publish the software is to use the Software Heritage Archive. And the one missing piece in this is peer review, because when you put something in a repository, it is not automatically reviewed by your peers. So the quality assurance has to go somewhere. It usually should happen in the actual software project. So if you do code review, if you have, for example, external reviewers or people that need to sign off on your software, that's a great way to do this. And there is another option that is slightly less ideal for software publication, which is software journals. For example, the Journal of Open Source Software, which is great because it gives you a DOI for the software. It provides peer review for the actual software, not the small kind of descriptive paper you submit with it. And it also archives your software on Zenodo, but it only does so for one version. So if you have a very agile workflow and you want to publish versions all the time, then JOS will not be able to do that, or other software journals will not be able to do that for you, provide peer review, for example, for every version. One of the main distinctions here to make is that things that are not software publication, and there's one thing you should still do if you create a package. You want to make that publicly available in a package repository. So put your Python packages on PyPy, your R packages on CRAN, etc., etc. Importantly, if you have a repository like GitHub or GitLab or Codeberg or something similar, this is great. This is great for collaboration. It's not a publication because it can be deleted. You can override all the version history, etc. So having a GitHub repository is not software publication. I've talked about this before. Zenodo and the platform that it builds on in VURDM have a software type in their own metadata schema, which tells people that what they're looking at is software. They provide DOIs. There are options for manual upload, automated upload, and also you can pre-reserve a DOI, which is great because you can put that into your CFF file even before you publish the software. So that's really a good version, a good option for publishing your software, and it's what most people use. And just to a quick spotlight on Software Heritage again, they have the Save Code Now button. So if you need to get an identifier and you can't or don't want to publish in a repository, you can archive your code there. And amazingly, Software Heritage give you identifiers for almost everything. They have identifiers for revisions, for commits or revisions in Subversion, for releases, for the snapshots, so whenever something is archived, for directories, which is the actual blobs of source code people are looking at, and also for single lines and specific files within the publication. So these are really, really helpful if you want to be very precise about what you're using. Right, let's turn to software citation and how it works for software users. I've already mentioned many things that are also important for users, and they'll reappear here in this part. I'm approaching that part of the presentation mainly through a number of questions that I had to ask myself in the past when wanting to cite software. Some of the answers to the questions I'm providing will be, or maybe, opinionated, and all of the answers, and perhaps even some of the questions, are incomplete. So I'm really looking forward for further questions you may have for the discussion and the Q&A after this. Okay, to get a better overview of what we aim to do in the end, it's a formal reference in a reference list that gives people information about your software. Ideally, this reference features the correct and the complete author person names, the name of the software, a version ID, a publication date, the publication platform, and an identifier, a unique identifier. If we can't get all the correct and complete metadata together, which you may find is sometimes the case, we should try and make a best effort to supply as much metadata as we can, and therefore some of the information may not be complete or the best version possible, but there's still a lot of things you can do to make the software citation work. Right, questions. So, when to cite software and at which level? And my answer to this question would be cite software whenever it represents relevant previous work to what you're doing. So there is a case for citing software versions, and that's whenever you've used software to get to your research results, or when you discuss or compare software and the different features or properties, and also when you use them in your own software. So make sure that you cite the software that you use in your own software. Citing the properties or features of software when you compare stuff is relevant because these may change over versions, so cite the version in this case. And citing software in your own software can be done by listing them as references in your CFF file, like I said before. There are cases where you want to cite the software project, and that's when you discuss properties of the project rather than the version. So this may be something high level, such as the general type of software. Also, when you list software as examples, you probably don't want to cite a specific version, you want to cite the project. Next question, which software to cite? So cite the software that you've used or you discuss directly. And this means cite the software that you have run to process data, and data processing really is meant here in the widest possible sense, including models and simulations, CLI, command line tools, graphical applications, things you run in notebooks or from scripts, etc. If you have run a script that basically uses functionality from one or a few specific packages, it may also be relevant to cite not only the notebook, but also these packages. And if you develop your own software and reuse other packages as dependencies, and you want to cite them, which I think is a great idea, cite the direct dependencies only. Cite them in a reference list, because if everyone does that, then we'll have a great graph of citations to different software packages. Right, do you want to cite only the software? As far as I know, there is not yet a widely enough accepted standard for providing metadata for usage. So to enable reproducibility, if you discuss results in your paper, for example, and you cite software, also try to provide usage metadata and usage information so people can actually try and redo what you've done. There are some ways around this, or some ideas of how to supply this metadata. One is research object crate, which is a linked data format for describing basically a piece of research, including everything you need, data and software, etc. Computational workflows in some disciplines help, and containerization may also help. but like I said, I don't think there is yet a standard that works across the board. Also, if the authors ask you specifically to cite a paper or other work, do that. Do them the favor, because their career may depend on these citations, but also make sure that you cite the software itself. This is an interesting one, and it's where to get citation metadata from. So in an ideal world, all research relevant software should be packaged and distributed with the correct and complete metadata for the specific artifact that you have in your hands or on your computer. But often this is not the case. So you need to know where to look for these things. Software distribution, maybe, perhaps that includes a citation.cff file or other documentation that can help you out. Sometimes the user interface will help you. So try the help flag, or if you have a graphical application, look at the help menu, and there's often a item called about that gives you some information. For open source software, it's actually more easy than for closed source software. So if you go to the source code repository, if you know about the source code repository, if you find a DOI or any sort of link to a published version, then go there, use the metadata supplied with that published version, and you'll be fine. Also, citation metadata files, like I said, are fine. So citation.cff, code meta.json, or even .zenodo.json are very likely to contain a better version of the metadata than you may be able to guess. If you find a link to a release in a package repository, like PyPy or CRAN, have a look. Don't be too sure that all the metadata is correct. Don't make any assumptions. Also, don't try to guess metadata. But sometimes there will be other links as well in the package repository. The Software Heritage Archive, like I said, is also a good idea if it's an archive project. But if it doesn't have a metadata file, you won't find much of the metadata apart from the PID. Closed source software, you don't have many options. Either you have a manual that tells you who the creator of the software is, when it's been published, etc. Other than that, use try and find information via the user interface. We want to make our research software open anyway, right? Which software citation metadata to trust? I would argue that generally the PIDs, so DOIs, for example, that often have metadata attached to them, like you can look up in a registry, like Crossref, for example, or DataCite. This is one of the most trustworthy metadata sources because people will make sure, ideally, that the metadata they use for publication is correct and complete. The authors themselves are also a trustworthy metadata source, but there are potential pitfalls in both these cases. So, for example, if people use publication automation, you may not be able to get the correct version of the correct name of the software, and also not the correct list of authors. So the example I've given earlier, where Zenodo used to use the GitHub API if it can't find a CFF file in the repository, that'll give you weird software names. And also the author list will probably consist of all the people that have contributed to the repository, which is not the same as the list of authors. And that's what I've talked about when I talked about kind of trying to find out what software authorship actually is in that Research Software Alliance task force. Also, the source code repository may contain metadata files, but they may be unmaintained. So one recommendation I really have is compile the metadata carefully, do cross checks. So look at the version that the -- version flag may give you on the command line, and look at the version that's in the citation.cff file. Make sure they match, and don't guess any metadata, because guessing metadata will probably give you a worse result than using some of the strategies I'll talk about in a second. What you really shouldn't use is version control or package repository metadata for authorship, because these will almost always be incorrect, apart from when you have no other option than, for example, to use a commit hash or a revision number to provide some information about the version you were using. There are some strategies, like I said, about how to deal with missing metadata. So for authors' names, if you don't have them, use a group author. It's not something that I would recommend software projects give people to cite, But if you're a user and the software project hasn't given you any metadata, use a group author, call it the software name authors. That's good enough. It's better than not supplying anything or supplying wrong data. Software name is not really all that important if you have a PID, so use something that makes sense. The version identifier is interesting. If you can't find something that adheres to something like semantic versioning, you can use a tag, a git tag, or a commit number, a revision identifier. What you can also try and do, if you have neither of these things, you can calculate the MD5 checksum for the files you've used and supply that. It may give people a better idea of whether they're looking at the same thing if they found it. If you don't have a publication date ready, use the tag or the commit or the revision date you can find, if there are any. And if you don't know anything about the platform, and if you don't have an identifier, you can always go, in many of the cases in open source software, and archive the repository yourself. But that means that you have to have a repository to archive. And this will give you a software heritage ID of some sorts that you can then use as your PID, and software heritage will be the platform that you can use, the publisher, so to speak. Right, I'm coming to the end of my webinar. So how to format the software reference. There aren't many citation styles out there that actually support software as a specific type. BibTeX as one of the formats that you can use for citing stuff when you compile LaTeX documents does not support a software type. It has an alias. So basically, if you can use something like @software for the type of your reference, but that will just resolve to a miscellaneous type, which doesn't give you any of the fields that you need in your software citation. So you may have to actually hack the style to include all the relevant metadata. For example, to include the version identifier, you can just use the title field, and you can add brackets and put the version in the brackets. However, if you use LaTeX, I suggest that you also use BibLaTeX. And if you use both, there is a great package which provides a style extension for software references that's been developed by Roberto Di Cosmo, also the lead of the Software Heritage Project. And this style includes extensions for references to software projects, to software versions, to single modules within a software project, and even to code fragments. And so I've just put in 2 examples here. If you have a chance to use this, use it and make sure you cite the exact piece of software you want to cite. That's it. I'll come to the end. So some key points just to summarize. Software citation is important because it acknowledges the importance of software itself in research. It also can help to improve the reproducibility of research, and it provides credit so people that do the software work may be able to build a career on this credit in academia if they're so inclined. Software citation relies on the correct and complete metadata. And if you are a software developer or a maintainer or responsible in any way for a software project, you should provide the citation metadata together with the project. One example I've talked about a lot is the citation file format. You can use this format, you can use other formats as well. See what your community uses and what's being used in your discipline. For CFF specifically, there is a lot of tooling available to help you create and maintain the citation metadata, but also a lot of work in progress still. Software users should cite software projects or software versions whenever you use them. Software developers should also, and this kind of goes back to bridging being a user and being a developer, you should cite the direct dependencies that your own software relies on. And as a sort of major key point, it is still quite a complicated field, software citation. And to make it better and to make it establish practice across academia, what we really have to do is work on changing the culture, make sure that people acknowledge and accept that software is an important output of research, and also we need resources and time and funding to create better tooling for bridging some of these gaps in the tool landscape, but also to deal with some of the very specific challenges you have in software citation. And that's me. Thanks very much for listening and coming to this webinar. And I'm really looking forward to now look at the Google Doc and some of the questions.
Yeah, thank you very much, Stephan. That's a great discussion, and I think we have a few questions here. And once we get through what's in the Google Doc, we might be able to open it up for general discussion if we have time. So you've already answered one question that's come in. We have another that mentions various websites for publishing data, and there's an example given there. Is it good to use these sources or archives for publishing data to publish code, or is something like GitHub better for code?
So like I said, GitHub, to start with this, GitHub is not a publication platform. It's great for working together with other people on your code or on your data, if you want to use it for that, or even papers. Generally, it's definitely possible to use data platforms for publishing software. Zenodo is one example. I think they probably started out as a typical RDM solution, so people wanted to publish data, but they've also gone through the effort of making it work for software. So this is a good example. There are other repositories that won't be able to provide all the things you'd ideally want for software publication. So some of the platforms don't include a software type, for example. They may have the usual types you get in, for example, in BibTeX as well. So papers, monographs, theses, data sets, if they're relatively modern and up to date, but software sometimes you won't have. And to have a software type makes it possible, especially for services that want to work with the metadata, but also for researchers such as myself who are interested in finding software in repositories to determine whether the thing you're looking at is software or is a data set. So I guess the answer is it depends. If the repository, the data repository supplies all the metadata fields, for example, you want for software, that's fine. So the usual ones are, like I said, software type, versioning, which you I guess probably have for data as well. You may have different licenses. So if you need a license to publish your software, a lot of the data repositories will have Creative Commons licenses, and those are not usually recommended to use for software because there is a lot of open source and other licenses that pertain to software specifically. Yes, I'll stop here. I think it depends, but it may be possible is the short version.
All right, thank you. Next question, what are other good software journals besides JOSS, especially for open source software?
That's a very good question. I have only ever used two. So I've used JOSS, I've been an author for JOSS. There is a smaller journal called the Journal of Open Research Software, and that's used to be edited by the director of the Software Sustainability Institute, Neil Chuhong, and they have two interesting tracks. One is probably not that interesting to you if you're a developer, and that is research software issues, I think it's called, or issues in research software, where you can actually discuss some of these things, for example, in software citation. And the other one is software papers, and I haven't authored a paper and submitted it to JAWS in terms of a software paper, but that's the other one I would be looking at in addition to JOSS. JOSS is really great. They have a great workflow. They have a large community. It's well maintained. It doesn't cost you anything, which is a great thing, you know, for an author. There are, of course, the other software journals that are run by the bigger publishers. There is one run by Elsevier that I think has basically copied the model from JOSS, as far as I remember correctly, some of the comments I've heard. It's up to you if you want to submit your software to any of these journals, but in general, I'd say if you need something more more understandable for your PIs, for example, and you can't just give them a Zenodo DOI, try JOS. JOS is great.
Thanks. I'll just mention the Elsevier public software journal is Software X, I believe.
Yes, that's the one. Actually, there are some. I need to look it up, but there is a journal that I think it's from the imaging community, and they also do software papers, and they do automatic archiving and software heritage. I would have to look up the name, but that looked like a very interesting model. I've spoken to one of the editors there once. I'm sure I can put in the name of the software in the document after this webinar. Yeah, there are domain-specific journals such as ACM Transactions and Mathematical Software as well. That's true. PyOpenSci does peer reviews on software. So I guess it depends on what you're looking at. If you really need a journal that's called a journals of something, JOS is a great thing if you're looking for something discipline specific. The ACM Transactions would be interesting, or the imaging one. Yeah. Maybe you don't even need the journal name, and then you can go with something else.
Yeah. All right, and thank you folks for the comments in chat. We'll get those transferred over to the Google Docs so that that information is there, and then Stephan can add a little bit to it. For the archives, we will, I think, move on to the next question. What is your experience and advice for citing contributors whose contributions are often not captured by Git commits, such as those who contribute to requirements, analysis, and design?
That's a very good question. It's one that we're working on and trying to come up with some halfway general guidance for projects in this research task force I was talking about. It is a really difficult thing. So I'd say in general, the recommendation is, as a project, think about authorship as well as all the other things you have to think about, ideally early on in the project. It's not something that we're very used to doing at the moment, but it's something that needs to be done, especially in research software, where it's important to be clear about authorship because it may have consequences in the real world. I've very briefly mentioned this concept of making a substantial contribution, and in the research task force, we have drafted some guidance that provides 4 criteria to which people can make a substantial contribution. And what substantial is really up to identify for the software project. But if you make a substantial contribution, it doesn't have to be that you have to push code or some sort of file to the repository. And there are many roles who may never touch the repository, but are still crucial to the software project. You have, requirements, analysis, design. You also have community managers, for example, that may be crucial for sustaining the software. And these people, I would say, would usually definitely qualify as authors. So it's really, I'm afraid, down to the software projects to think about authorship, make sure they document how they handle authorship. Also between versions, for example, some projects just keep getting a longer and longer author list because people are just being added. Other projects decide to look at who's contributed to a specific version and only identify those as authors who've contributed substantially to that very specific version. So there are different things to consider. Hopefully, the guidance that we're developing at the moment will help you think about some of these questions and tackle some of these challenges. And we'll make sure to get the community's input on the guidance as well. And that's one of the next steps in the work of the task force.
So in this vein, I'm aware of something I think comes out of the publishing community called the credit taxonomy, contributor role taxonomy. Is that something that you would consider relevant?
Yes and no. This is actually the second work package that we've given ourselves on the task force to look at contribution roles. And we started this during a short hack event at the SSI Collaborations Workshop in 21, I think. So quite a long time ago. Taxonomies can be really helpful in doing this, but there are quite a few out there. So we wanted to look at what guidance people give, or what recommendations we can make about these taxonomies. And one thing is that the credit taxonomy is great, but not for software, because it only defines and identifies a single role for everything to do with software, and that's not sufficient for tracking contributorship for a software project. So, and there are other vocabularies like the all contributors tool, which is a very kind of hands-on way to track contributions to mostly GitHub repositories. And this is really great. It has a large number of roles, so this may be too overwhelming. Perhaps there are roles missing, but we really want to sit down and look at these taxonomies and see if we can find something that perhaps sits in between the kind of high-level credit taxonomy and the very specific all contributors taxonomy, so that people can easily understand the roles, also make sure they're well defined, and so they can actually use them for their own projects. And there are a couple of others, and I can share links to them as well in the document.
All right, very good. We just have a couple more minutes, and we have several more questions, so let's try to move on maybe. We have a question about dynamic software. My package works on a plugin system. Citing the framework doesn't give the plugin creator proper credit. Citing all the plugins that are used could conceivably lead to hundreds of citations.
Yes, very good questions. I really like this one because it touches a bit about kind of some of the things you think about in the humanities, which is, like I said, my original field. What even is a software, a piece of software? We have some intuitions, I think, about what we are talking about when we talk about software or packages or modules, but this may differ completely. And also because software is such a dynamic thing, especially through the development process, where you have tiny increments to every new version, it's a really good question to ask. I'd say that dynamic software is just software. Every software is dynamic. So how can this work? Your package works on a plugin system, which is great. It's great practice. I'm afraid the only thing I can really say about this kind of that tries and get near anything practical would be look at how you manage the framework and look at how the plugins are managed. And if they're sufficiently far away from the framework, I would probably argue that these can be identified as a separate piece of software, of work. There are no rules about how large a piece of software has to be citable. There are probably, again, some intuitions around this. So a script of, say, 15 lines that does something that ChatGPT has given you is probably not, it's definitely not citable because it's ChatGPT, but that's another question. So why not make sure that all the people that deserve credit for the work and all the information that you need to rerun the experiment, for example, make sure that you provide the information for those and that you cite those. If it's 100 plugins you have to cite, that shouldn't be much of a problem. I mean, PDF space is really cheap. I know there are limitations, but we've seen in high particle physics that you can have thousands of authors, and it's not a problem. It may be a problem for humans, but it's not a problem for the artifacts that you produce. I think that having a limit on the number of references you can put into a paper is not really something that I understand very well, because why wouldn't you have 200 references in a paper if that's what it takes to make sure that people understand the previous work that you build on? So the other angle is the one of accumulating and also kind of gaming the citation system to accumulate very many citations for, say, 20 different plugins you've developed if you cite them all. That's not a problem of the software. That's not really a problem of the functions of software citation I've discussed. It's more a problem of the system, which doesn't want to be hacked or gamed because people are very serious about counting citations, etc. So it's a very good question. I don't have a very good answer, I'm afraid.
Well, good attempt there. So we're at the top of the hour, but if folks want to hang around for a few minutes, we'll try to get to the last two questions that we've got. We need persistence of the code and the data we want to be able to cite. Are you aware of any data or code publishing platforms that have ever been taken down?
Publishing platforms, no, but I also don't have a good overview of all the repositories that are out there. This is, I guess, also a very current question in the light of things happening in some parts of the world right now. Yes, they should persist. Also, we should make an effort to make them persistent. But even more important is that the metadata persists, because knowing that something had existed in terms of just looking at software citation may be more important than having the actual artifacts. And this is why it's said in the software citation principles, the metadata should persist even when the software is gone. I'm not aware. I also don't have any practical guidance to pick a repository. It's likely that the bigger names, such as especially the general purpose names like Zenodo, won't go away. Dryad hopefully doesn't go away. Michael just wrote in the chat there, Google Code is a good example of why you shouldn't consider GitHub to be a publication platform, because Google Code is gone. A lot of software has been developed using Google Code. Thankfully, the Software Heritage Archive archived the whole of Google Code, so it's all still there. But that's also a good point, because it shows why software heritage is a very good option for preserving and persisting the code, even down to the level of commits and of the whole version history. And there is no reason why you shouldn't, just because you publish something in a repository, not also archive your software in software heritage. We don't know if it's going to be around in 20 or 50 or 100 years time, but we don't know if anything's going to be around in this kind of time span anyway. So sorry, that's the best I can say right now about this. I'm not personally aware of any publishing repositories that have gone down. Registries, yes. Indices or catalogs of stuff, yes. But repositories, I'm not sure about, because hopefully these are taken seriously enough to also be maintained within the institutions that are responsible for them.
I believe that for DOIs, there is some kind of persistence requirement. I don't know that you have to actually preserve the information indefinitely, but at least you have to have the metadata, as you said. And even if the original DOI host goes down, there needs to be some kind of backup plan for that or something as part of being a licensed DOI provider.
Yeah. Well, I guess that's true also. There are legal requirements for or regulatory requirements, at least for some of the repositories and in institutions here in Germany that have to, make the backups on tape and preserve those for 10 years.
Mm-hmm. So one last question. I observe in our package development, the package starts with a blank template to be filled out with info like author name and email, maintainer name and email, etc. Does this make life easier than in the past?
It may. I think it probably does in some respects. So having to do this before you actually can start development, thinking about the author or the authors is definitely a good step in the right direction. I think the problem is always in the maintenance and in the maintenance effort you have to make to maintain the citation data along with the software. I mean, if you set up the Git version control system on your computer, you have to give that some sort of configuration with a name and an email. But also having to think about who the authors are and who the maintainers are early on is definitely a step in the right direction. I'm not sure if it's, I'm pretty sure it's not everything, it's not enough. But I think the R community and the R ecosystem in general is pretty good at making sure that all these things that sort of float around the hardcore software development tasks only are really well covered. So I don't use R myself, but the things I see in the R community are really good. Like things like R OpenSci, for example, take very good care of getting many things right. So it's definitely a step in the right direction. I hope that if you don't use R, you can always go and use CFF init, the citation file format initializer, and find that easy enough to work with. And hopefully along the road, we'll have some better and kind of more general tooling for people to maintain the citation metadata as well.
All right, very good. I think we've exhausted the questions in the Q&A doc. We've probably exhausted Stephan in answering them, and we are well past our usual hour. So I think we should close it there. Thank you all very much for attending, and thanks very much to Stephan for this excellent webinar. Thank you all.
Thank you very much.